By APIs are boring, I mean APIs are actually a mature technology, which means most of the stuff out there is, the API itself is figured out. Now, most of the developments, most of the excitement comes around different ways we can bring productivity to developers. If we can take these fundamental units of what developers normally do and have an engine that enables those things, then it brings that value to every developer who uses the Supergraph. So you never have to write an N+1 style optimization ever again. Supergraph is not a new idea. In fact, creator of GraphQL in 2012, right? These guys are already talking about entity-based models, which means they're already sort of modeling the domain and then having that entity model figure out how these queries are executed. This is Entco. This is from Facebook. Here, Hasura.io/Supergraph, which has linked to several other companies who've implemented this as their success story for GraphQL. So please check it out. And here's some stuff built on Hasura, different Supergraph built on Hasura. So the cool thing is over here, just to emphasize, you can bring all sorts of different data sources into your Supergraph. Postgres, MySQL, MongoDB, TypeScript functions, their own REST, OpenAPI, whatever you have, right? You can bring that into your Supergraph. And once you're there, you can model all the relations between them to build your domain out. Hi, everyone. Nice to see a lot of faces. Nice to see a lot of challenging questions. I hope you have some more for me at the end of this. So I'm Akshay. I'm from Hasura. I currently lead the DX effort for V3 DDN. Let me jump right into a demo and show you guys what this is all about. So here's an empty directory. And the first thing I'm going to do is say Hasura init. Whoops. And I'm going to create a new project. And now it's going to go to Hasura DDN, which is our cloud hosted version of this project, and create a project for me and set up a scaffolded project. So this is what that looks like in VS Code. So don't worry about the code as much. I'll walk you guys through it. I just want to share how cool this is, basically. So I'm just going to commit the initial scaffold. And now, let's say I have a Postgres database. And here's a sample Postgres database. That's from our Getting Started guide. And let me check that out. So here's the tables in this Postgres database. So this is an e-commerce sort of application. So the data modeling is done. If you're an awesome developer, you probably focus a lot on your data modeling before you get into writing your code. So this is that data model. It has carts, it has cart items. Let's say every cart item has a product associated with it, your standard e-commerce stuff. Yeah. And now what I want to do is I want to have an API on top of this data model. And what I'm going to do is go ahead and write another command that is going to add that Postgres database to my Hasura project. All right, that's done. And let me just run Hasura 3 watch, which is going to pick up any changes to my project and then deploy it and get me a new API when things change. I'm going to say yes and run. All right. Meanwhile, let's go to VS Code and see if we've sort of picked up anything from our database. Whoops, let me see. Not yet. Okay, all right. Error, let's see if we're up. Okay, sure, I'm just killing this. And there we go. All right. So watch mode is running. It's making a build and we have something, but it's not going to really have our database yet. and see if this works. All right. So what the VS Code Hasura extension is telling us now is that this database has several tables that I can bring into my API. Okay, let me just go ahead and add all of them. Okay, so it's generated some configuration, and I'm just going to leave it at that for now. Let's go back to our watch mode, and I think it just triggered another update. And do I need to save something? Let's see, save, and then it triggers a build. And then I'm just going to go to my console URL, which is where I can begin executing queries against this. All right. So I've been testing out Todd and I stumbled upon an edge case, but this should not happen to you at all. All right. And here's our API. So this is our GraphQL API. So we've gone from our database, our data model, and we've already gotten an API. Let me prove that to you. Let me get all my cards. And for each card, let me say I want to get the card items. I want to get the ID of the card item. For each card item, I want to get the product. Maybe price. All right. And there we go. And that's our API. So, like, what happened here, right? How can we go from a data model to an API so fast? And that's what I want to talk to you about today. So the title of this is Build Supergraphs, not APIs. Now, why would I come to a GraphQL talk and say this? Because the GraphQL is awesome, but there are several different ways to build a GraphQL server. And that's, I think, what the key takeaway that I want for this talk to be today. Let's get into it. So what happened when I ran that, when I clicked that plus command in VS Code? Thank you. When I clicked that plus command in VS Code, what actually happened, right? So clearly, it figured out how to make an API from my table. So we're going to see how that works and why that's a good idea. So let's say I have a posters database and that has a products table, a categories table, and I want to bring that into my API. We're not going to build an API. We're going to build a supergraph. So what's a supergraph? I have a products table. I'm going to bring that as a model into my supergraphs. I have a categories table. I'm going to bring that as a model into my supergraph. So the code that we saw generated in VS Code simply configures the Hasura server to access that model. So for the products table, for example, that's the definition. What does that say? It says, okay, this model is named products. The source for that model is this database and this table name, which is on the bottom over there. And also configure some additional stuff about the GraphQL thing. For those who know GraphQL, it's like, what are the root fields? What should they be named? That's like a configuration you can apply. And that's it. You're done. That's already part of your API now. Okay, let's bring in another table, categories table. Same thing. I make a categories model. What do I need to say? Name of the model. What is the data source for it? Which database? Which table name? And then you're done. So we bring in models, but let's go further. Because a graph isn't just a bunch of nodes, right? The relationships are where the power comes from. So let's define a relationship then. So we say the source is the products table and the target is the categories table, and that's it. So that defines edges in our supergraph. So far we're just setting up our supergraph. So what happens when you set up a supergraph? So here's the thing. You would have noticed that these are just YAML files. The declarator approach is awesome. SQL, I'm a big fan of SQL. In SQL, you basically tell the thing, hey, I want this to happen, and the SQL engine goes and figures out how it should happen for you, right? And that's exactly what we do with a supergraph as well. So we declaratively define the entire data domain. We basically specify what our data looks like, where our data comes from, what are the relations between data, some more cool stuff which we'll get to. And the Supergraph figures out everything else. So once we have this built out, we get an API on it for free. So what's the advantage of doing something like this? But in the same way that, for example, if you give a query to RESTful engine, right, it can figure out the most efficient way to execute your query. The same thing happens here. So once you model the domain, the Hasura engine can figure out the best way to execute those queries or mutations. Here's an example of GraphQL queries that you can execute. Now, I didn't write any resolvers. I just specified what my domain model looks like, what my data model looks like. And I can already begin to do queries like this. So, okay, let's make more stuff come to our Supergraph. Here's a different database with some more tables. It has a users and orders table. Bring that also into the Supergraph. I have some functions, let's say some Lambda function somewhere, some TypeScript functions. I can bring that also into my Supergraph. And once all these things are there in Supergraph, I can model relationships between them. And the Hasura engine lets you do cool queries like user to orders. Now, users to orders is in the same database. So you can guess, all right, fine, it's doing something, but it's actually doing something cool because it will actually compile this into a database level join. Because users and orders are in the same database, right? Which means if I have a GraphQL query that gets me the users and all their orders, that should be a join. But you don't have to actually write that out. You don't have to hand optimize it because the engine will do it for you. Let's go one step further. The orders, under orders, I have products. Now, products is coming from a completely different database. Now, what do? Like, do I get back all my orders and then do n+1 query for products? No, I mean, you can do better things. For example, you can get back all your orders, and now you have all your order IDs, right? Or product IDs. Now you can make one request to your other database and get all your products back. And then the engine will join and return it to you. What are the other cool things we can do over here? Well, stuff like filtering, ordering, grouping, aggregation, all these things are things that the engine will give you. So you don't have to handwrite again. What about this validate order thing? That's a TypeScript function. Now, what if I could filter my orders posters table by a TypeScript function on that table? You can do stuff like this. So whatever your data source is, whether it's a function or a Postgres table or a MySQL table, some other relational table, your MongoDB collection, bring all of it into the Supergraph. Just declaratively configure what your domain model looks like, what your models are, where they come from, what the relationships are, and let the engine handle the heavy lifting. I mean, like how many times have you thought about writing a resolver to optimize some n+1 query, or your ORMs to optimize an n+1 query, right? This is repetitive work that's not really interesting. Let the engine do that for you, like focus on the interesting bits. So what else can the engine do for you? It gives you mutations. Mutations have, you can do nested stuff. You can return, like returning star. Basically, whatever native functionality that database has, right? Our goal is to expose most of that to your API. All right. So APIs are boring. Yeah. But this is a good thing. So when you think of an API, what you should really be thinking of is the language the server speaks, not really the implementation. Like, for example, if I have a REST API, I can implement it in JavaScript. I can implement it using Ruby on Rails. I can implement it in something else, right? But like, whatever, we know all of those are going to work roughly the same at the end of the day. Same with GraphQL, right? And in GraphQL, again, there are several different ways of implementing GraphQL. So GraphQL is cool, but let's sort of explore and broaden our minds about what are different ways we can actually build that GraphQL server out. And by APIs are boring, I mean APIs are actually a mature technology, which means most of the stuff out there is, the API itself is figured out. Now, most of the developments, most of the excitement comes around different ways we can bring productivity to developers to actually build out their APIs, different ways we can enable developers to actually deploy at huge scales and performantly without doing a lot of that manual work, stuff like that. So the implementations are where the excitement's at. So CRUD by itself is extremely boring. That input output, get some data, put it in the database, read some data, give it to other side. And the more you handwrite this, the more you realize this is repetitive work. A lot of that joins and stuff you don't really want to write every time. What else? I mean, yeah, every time you write that handwritten API, it changes a little bit. So your guy who developed the mobile app now has to look up what the exact API is. Like, they're all slightly different. You have all these issues, right? You don't really want to do this. But I think SQL was a great success story. Like, I really have a lot of, I really like SQL a lot. Like, whatever data you give to Postgres, right? You can get out that data in so many interesting different ways. Like, you can do filtering, you can do joins between anything, between different tables. You can do aggregations. This isn't fitting enough for you, you can write your own function inside Postgres and you can get it out. And the whole thing is declarative, which means I just specify what I want and Postgres is smart enough to figure out how that data should come back to me, right? And then, like, that was such an awesome model. And in fact, that model still holds, like, for many use cases. Like, if I'm building a mobile app, probably I'll just build that on top of SQLite or something. The abstraction layer will be very thin. But, I mean, what happened to us when we began developing servers? Like, where did we lose our way? And I've seen, like, sort of horror stories where there's a Postgres database and then there's an REST server sitting on top of this. And then someone said GraphQL. So then people took that REST server and then they wrapped each REST endpoint in a GraphQL resolver. Then they said, hey, wait, hold on. There are many of these GraphQL servers around. Let's build one more layer on top of it for federation. And now every query, right, has to go through all these different layers. And by the time it comes back, you get multi-second latencies. And this is simply unacceptable. Also think about the maintenance overhead. I mean, why are we maintaining so many of these layers? So SQL is awesome, but maybe there were some small features that weren't there. Maybe it didn't have some application features. Maybe the DX of developing that custom business logic was not good enough. Maybe it didn't support features like application level, application side users, right? But we were almost there, I'd say. And the more layers you build on top of it, the more it just obscures what's going on. The more it just becomes a burden to actually maintain and run. Data is interesting. So if you look at the people who actually bring value to a business, those guys will be sitting very, very close to the domain. Because most of the value comes from understanding what the business needs are and being able to translate that into a domain model. And that is where the magic really happens. After that, implementing the APIs, I mean, sure, like you said, there are several different ways to do it. So what if we could empower every single developer to basically focus on this valuable bit of work, to focus on the domain model, which is basically stuff like the schema, which is stuff like validations and permissions. Even if you have things like processes, you can basically encode that as a domain model. You can have multiple steps basically that are tied into a workflow, and this can be your model, right? So most of the stuff that we really wanted to do, which like beginning of programming, we learned in object-oriented programming, take something in the real world, model it as an object in your system, and then there's a mapping, right? That's most of what we really want to do. So let's focus on that bit that really brings the value. And that's the goal of building out the Supergraph. So you use GraphQL, but where is your graphs? I mean, like this is not really a trick question. Like a lot of people have different takes in this, but I think the reason that we love GraphQL so much is because every underlying data source can be modeled as a graph. And why is this important? It's only important because you can take one graph and a different graph and you can join them. You can compose them. If I have a different table, I can simply take that table and I can join it to my graph. And this composition is where all of the power really comes from. Because as soon as I take a different domain, a data domain, or a different table, or a different data source, and join it to my existing graph, now the relationships are where the power comes from. The fact that I can take one data source and filter it on another data source, or the fact that I can now run analytics queries across my entire business. Like, this is the cool stuff about graph-based modeling. So this is where I think the value really is. Oh, sure, you can write stuff like resolvers, and resolvers are like powerful low-level stuff maybe, right? When you want to actually express every detail of the implementation. But there are a lot of times you don't want to do that. Like a lot of the implementation details, for example, how you want to join from one table to another, how you want to do N+1 queries, how you want to take one database and join it to a different database. All these things are things you find yourself writing again and again and again. This is not valuable to do. This stuff is much better done by the engine, so you can focus on the valuable stuff. Same way in SQL, SQL does your join for you, right? At that point, you don't write that join in your application level 4. It figures it out for you. The way Postgres will do join is far more efficient than the way you will do join, because that's one layer removed. That's inside the engine. Same way, if we can take these fundamental units of what developers normally do and have an engine that enables those things, then it brings that value to every developer who uses the Supergraph. So you never have to write an N+1 style optimization ever again. Supergraph is not a new idea. In fact, creator of GraphQL in 2012, right? These guys are already talking about entity-based models, which means they're already sort of modeling the domain and then having that entity model figure out how these queries are executed. This is Entco. This is from Facebook. Here's Goldman Sachs from a lovely talk at one of Hasura's enterprise GraphQL conferences. And what they do inside their organization is every piece of data, right? Like they have multiple teams and with multiple databases, multiple tables, multiple CSV files even, Excel sheets, all of it is taken and put into this Legion system. And then they can model these relationships across their entire company. So they're already building Supergraphs actually. What else can we do? And that Supergraph is actually kind of cool because once you have that Supergraph set up, today we support GraphQL on top of it. But tomorrow we can support any API on top of it. We can support REST API on top of it. You can support something else, gRPC. So possibilities are endless once you get the domain modeling right. Here, Hasura.io/Supergraph, which has linked to several other companies who've implemented this as their success story for GraphQL. So please check it out. All right. And here's some stuff built on Hasura. Different Supergraph built on Hasura. So the cool thing is over here, just to emphasize, you can bring all sorts of different data sources into your Supergraph. Postgres, MySQL, MongoDB, TypeScript functions, your own REST, OpenAPI, whatever you have, right? You can bring that into your Supergraph. And once you're there, you can model all the relations between them to build your domain out. So your source can be anything. And today as a Supergraph API, we sort of support GraphQL, but we want to support more stuff going forward. Yes. So now that your Supergraph input is just a GraphQL query and your engine is executing it for you, it can figure out the most efficient way to do things. If it's join in a single database, it will do database join. If it's join between different databases, it will do batching. Stuff like that. It will do tracing for you. It will figure out which queries it can execute in parallel and which need to wait on each other. It will do explain query for you. So it's basically a query engine, right? Your GraphQL is getting compiled into some underlying database queries. So it will basically show you what that compiled queries look like. So here, for example, it's done two things in parallel. And then for each one, and then it's done some hash join at the end of it. And for each one, you can sort of click through and see what the underlying database queries actually look like. So if your tracing shows some bit is not performant, you can actually drill down very fast to your actual database query and see what's not performing, and then go and optimize that. So there's a lot of visibility, even though the engine handles all this compilation, all this performance for you. You get a lot of visibility into how it works. Let's look at another cool thing. Here's the TypeScript function. Now this side function takes two arguments, which are both numbered high. Its return type can be derived as number as well. And if you look at this side function, all of its inputs and outputs are already well defined, which means this should be sufficient for me to get an API. And it turns out it is. So if you have this hello function, you can bring it into your Supergraph with this declarative YAML. So what does that YAML tell? Basically the same thing. What is the name of the command? Where should I go and look for this function? If you have a sum function, again the same thing. What is the name of the function? Where should I look for the function? What is the source basically? Also stuff like arguments. Okay, there are two arguments X and Y, both are numbers. The return type is also a number. And this is pretty much all you need to define to bring these functions into your Supergraph. And once in your Supergraph, of course, they compose. Now you can join this with everything else and all that stuff. So you might also have thought, okay, if I bring only my poster stuff into my Supergraph, what happens when I need to have some custom business logic? And this is pretty much the answer. You're never limited by that paradigm. If you want to have a query that we don't support today, that you want to have a more complex mutation that we don't support, you're always free to write those bits out. But once you've written those bits out, they compose with everything else. So it's not like you wrote something and it has to live in its own silo, right? You wrote your own function, it still works with everything else. It still joins with everything else. So that's the cool thing. Let's see. This idea about taking your type functions and automatically bringing that to an API, right? That's also being developed by several people in the ecosystem today. So if that's appealing to you, check out these tools. Graphs is a cool place to start. They basically take TypeScript functions and make an API from them. I think what I'm trying to emphasize is there are a lot of cool ways of building GraphQL servers. So if you use Hasura, for example, we'll bring that into your Supergraph and you can join them. But here are some other stuff that do TypeScript to GraphQL as well. You're not limited to just writing resolvers. There are a lot of cool ways to get those benefits of GraphQL. Okay, so you built a Supergraph. What are the other cool things you can do with it? Now, your entire domain model is somewhere, right? You have one place where your entire domain model is. Most of your permissions, if you notice, are encoded as some predicate on this graph. For example, user can see an order if the orders.user_id is equal to signed in user ID. This is like our common permissions. This is most of what we do. And those permissions can be declaratively defined in your Supergraph again. So why would you want to do this, right? One, it's declaratively defined, which means any query that you make to your Supergraph, this permission will apply. So it doesn't matter if you directly query the orders table, if you do user.orders, if you join it through some different table, if you use any filters, if you use any aggregations, it doesn't matter what kind of query you do. This predicate will always apply. The second advantage is that because the engine is taking your GraphQL query and compiling it into things like SQL, these permission rules are very efficiently pushed down into the database itself. So if you look at a join, like let's say you have a GraphQL query that has some join, these predicates will get added as where clauses in your SQL itself. So you won't actually have multiple database calls. You won't have a situation where you retrieve a lot of data and then you filter out at the engine layer. That sort of stuff doesn't happen. Like all the predicates are pushed down into the database layer. What else can you do? All right. So that's pretty much how the whole Supergraph thing works. Hasura DDN, Hasura v3 DDN is our implementation of the Supergraph. So with the Hasura DDN, what you can basically do is you can get your API and you can deploy it globally. Basically, we have Edge. So you have your engine sitting all over the world. If you have databases that are hosted in multiple regions, you can basically configure the DDN data delivery network to talk to all your databases. So it will route across all your data sources in read, multi-read, or read-write configurations. Check us out. We've put a lot of work into V3. We've taken all our lessons from V2, a lot of stuff what customers are asking for from V2, and we've built all those awesome ideas into V3. V3 supports a model where you can bring in any data source, including data sources that are custom, or your own business logic, or your own existing microservices. All of it comes very nicely, very smoothly into the Supergraph. So please check us out. Here is a link to try the Hasura DDN, which comes with an always free tier, which basically means until some limits, your usage will always be free. So please check us, sign up there and try it out. Join us on Discord. Come talk to us about like what's working for you, what's not working for you. Especially, I have a personal interest in the DX part right now. So is there a better way of doing this? Come share it with us. And we want to build more of that and make that more of that easy. Hasura v3 is open source. And here's a GitHub repository. It's a Docker Compose repository. So basically, you clone the repository, you run one command, you say Docker Compose up, and it'll have a complete Hasura v3 engine and connectors and databases all running locally for you. Here are Twitter handles to Hasura and my personal one as well. There's an underscore in the beginning of that. So come talk to me on Twitter. All right, that's what I have for today.